Hello friends, this is BM. In today's lesson, I'll be teaching you what is principal quantum number and what is azimuthal quantum number. Today's agenda are principal quantum number, its importance, azimuthal quantum number and its importance. First, what is principal quantum number? So as I discussed in my last video, according to Bohr's atomic model, electrons revolve around the nucleus in distinct paths called shells or energy levels, which are represented by n. This n is called the principal quantum number. So you all can see in the diagram, from the nucleus, the shell 1, 2, 3 and 4 are assigned as K, L, M and N. And in the table you can see for cell K the principal quantum number is 1. For cell L the principal quantum number is 2. And for cell M and N so on. Now let me explain you its importance. Electron configuration. What is electron configuration? Electron configuration is the arrangement of electrons around the nucleus. So the electrons of lower n orbitals. What are orbitals? Orbitals are the electron dense region around the nucleus. So in a cell, the cell is divided into subcell, right? And each subcell is again made up of orbitals. And in these orbitals, electrons are actually located. So the electrons of lower n orbitals are closer to the nucleus and have low energy. So these electrons are tightly bound to the nucleus and thus need more energy to be removed. Whereas the electrons of higher n orbitals, they are further from the nucleus, they have high energy and they are weakly bound to the nucleus and need less energy to be removed. Now the next point, energy levels. The principal quantum number tell us what is the energy level of an electron in an atom. How? The principal quantum number, that n, what is the value of n, means the electron is belonging to that number of cell. And from that number you can say what is the energy level, right? Like if electron belonging to the cell number 2, that means the energy level is 2. Or if it is 4, then the energy level is 4. So from this quantum number or n, you can say in which energy level the electron is actually belonging. Size of an atom. The principal quantum number also tell us what is the size of an atom. How? The principal quantum number means the cell number. So if the cell number is more, that means the energy level is higher. So there is the distance between the nucleus and the cell is more and the size of the atom will also be more. Next, periodic table. The principal quantum number corresponds to the row number of an atom in periodic table. This is because each period starts with a new principal quantum number. For example, if you go through the periodic table, you can see the magnesium is in the third row of the periodic table. And the principal quantum number for magnesium is also 3. However, there are some exceptional cases, like for transition elements, the principal quantum number is usually less than that of its row number. Next topic, azimuthal quantum number. So friends, you all know about the cells, right? Now, the cell are again subdivided into subcells. So like the cell, subcells are also named as S, P, D and F. And they also carry their own quantum number that is called the azimuthal quantum number. You can see in the table for subcell S, the azimuthal quantum number is 0, and for subcell P, the azimuthal quantum number is 1, and for D and F so on. Now the point is how much subcells can one cell hold, right? So that can also be determined from this azimuthal quantum number, and this azimuthal quantum number is denoted by L, and the value means how much subcells can one cell hold is dependent also in principal quantum number. How? For example, if the cell number or the principal quantum number n is equal to 3, the possible azimuthal quantum numbers are L is equal to 0, L is equal to 1, L is equal to 2, and that results into the subcells are 3s, 3p and 3d. Now come to the table. Here you can see for cell K, the principal quantum number n is equal to 1, where the azimuthal quantum number L is equal to 0 and the subcell is 1s. For cell L, the principal quantum number n is equal to 2 and the azimuthal quantum number L is equal to 0, L is equal to 1 and the subcells are 2s and 2p. For cell M, the principal quantum number n is equal to 3 and the azimuthal quantum number L is equal to 0, L is equal to 1, L is equal to 2 and the resulting subcells are 3s, 3p, 3d. And for cell N, the principal quantum number n is equal to 4. The azimuthal quantum numbers are L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3 and the resulting subcells are 4s, 4p, 4d and 4a. Now there is an easy trick to remember that subcell. Friends, the number of subcell that each cell can hold is equal to its quantum number. Like if the cell is L, its quantum number is 2. So it can hold 2 subcells, right? Like 2s, 2p. Like for N, the quantum number n is equal to 4. So it can hold 4 subcells, 4s, 4p, 4d and 4f. So starting from quantum number 1 to quantum number 4, there is addition of 1 subcell every time. Now, importance of azimuthal quantum number. The azimuthal quantum number describes which subcells are present in a cell. Correct? Like for K, the azimuthal quantum number L is equal to 0. That means S subcell is present in that particular cell. This azimuthal quantum number also describes the shape of orbital and its value is equal to the total number of angular nodes present in the orbit. So what are nodes? I told you about the orbitals, right? That is the electron dense region around the nucleus, and the nodes are opposite to the orbitals, means where the density of electron is 0. In my next video, I will tell you more in detail about the orbitals and nodes. And this azimuthal quantum number also determines the orbital angular momentum. Hence it is called orbital angular momentum quantum number. Thank you for watching my video.